Section 5.1 is on solving inequalities by addition and subtraction. First, we're going to take a look at the addition and subtraction property of inequality. You can add or subtract the same number on both sides of an inequality and it remains true. Very similar to solving an equation. And just to review the symbols that we're going to use in inequalities, we have a less than symbol, a less than or equal to, a greater than, and a greater than or equal to. And since our answer is not just one number, it's a whole set of numbers, we're going to use something called set builder notation. And it's written like this: curly brackets and an X, and then kind of a long vertical bar, and another X, our inequality symbol, and then our number followed by closed curly brackets. And we read this, the set of all X such that X is greater than 1. Then when we go to graph the solution of our inequality, I'm going to use a solid dot if it's a less than or equal to or a greater than or equal to. I'm going to use an open circle if it's a less than or a greater than. And the easiest way to do this is to write your inequality, your solution, with the x or the variable on the left, and then when you go to graph it, your line will be going in the direction kind of that the arrow is. So kind of think of this inequality sign as an arrow. X is greater than 1. Open circle over 1, and a line going to the right as the numbers on the number line are getting bigger. So let's take a look at a couple examples here. We need to solve and graph each inequality. So we're going to solve this just as though it were an equation. To start with, I'm going to subtract 8 from each side. Those cancel out, so I have x is less than or equal to 10. I'm going to write it in set builder notation, the set of all x, such that x is less than or equal to 10, close curly brackets. I'm going to draw a number line that has 10 in the middle, and one number larger and one number smaller. And since this is an or equal to, it's going to be a solid dot over the 10, and less than is going in the negative direction. Our second inequality here is 12x minus 4 is less than 13. Notice there's an x on each side, and I think it would probably be easier if I were to subtract 12x on each side. So those will cancel out and leave me with negative 4 is less than x. And I don't really like it looking like that. I want to have my x on the other side. So I can just flip the whole thing and write it as x is greater than negative 4. Notice that means exactly the same thing. My inequality is pointing at the negative 4 and opening up to the x. Putting that in set builder, it'll look like this, the set of all x such that x is greater than negative 4. And I'll draw my number line with negative 4, negative 3 to the right, negative 5 to the left. Since it's a greater than and not an or equal to, I'll do an open circle, and this one will be heading towards the right. Now for word problems involving inequalities, it can be a little confusing. It's a less than or equal to if it's using the words at most or no more than. And that seems kind of opposite. You're using a less than, but then you're using words like most and more. And it's a greater than or equal to if you're using the words at least or no less than. So greater than, and we're using words that sound less. So it's kind of opposite for inequalities. Let's take a look at an example here. Define a variable, write an inequality, and solve. The sum of 3 times a number and negative 4 is at least twice the number plus 8. So the first thing to do is define our variable. And I'm going to say let x equal the number. Remember, defining a variable means writing a let statement. So the sum of 3 times a number and negative 4, so 3 times a number plus negative 4, is at least, so remember that's going to be greater than or equal to, twice the number, that means 2 times plus 8. I'm going to clean this up a little bit. I don't like saying plus a negative number. I prefer to say 3x minus 4 is greater than or equal to 2x plus 8. Okay, now I'm going to solve this by moving my x's to both sides. I'll subtract 2x on each side. That's going to leave me x minus 4 is greater than or equal to 8. And then I'll add 4 on each side. And that's going to give me x is greater than or equal to 12. And I'll write my final answer in set builder notation, the set of all x such that x is greater than or equal to 12. And here's our last example. You have $65 to spend. You bought a shirt for $18 and a scarf for $14. If you want to buy a pair of jeans, how much can you spend? So let's define our variable. What I don't know is how much I can spend on a pair of jeans. So I'm going to say let x equal the cost of a pair of jeans. Okay, so I have spent, now let's write an inequality. I've spent $18 on a shirt and $14 on a scarf, and I'm going to spend X dollars on jeans, and I have $65, so that has to be less than or equal to $65. So the cost of the shirt plus the cost of the scarf plus the cost of the jeans cannot be more than $65 because that's all that I have to spend. So 18 plus 14, let's combine like terms. That's going to be 32 plus x is less than or equal to 65. And subtracting 32 from each side, x is less than or equal to 33. So let's not put our answer in set builder because it's actually asking a question. How much can you spend on a pair of jeans? Let's see, so I can spend no more than $33 on a pair of jeans. So in this lesson, we took a look at solving inequalities using an addition and subtraction, also learned a little bit about set builder notation and how to graph inequalities on a number line.